Hi, everybody. So, we're about to present Unplugged and Kinesthetic Computer Science Curriculum. So, I'm just going to start up the slideshow here. And basically, our goal was to figure out how can we better convey computer science practices and information to our students in a high school setting or a middle school setting. And it seemed that the best approach would be kinesthetic, as we have heard many times from the professor. So, we're going to go ahead and get started. When we looked into computer science framework, we found that these were the core concepts and practices for K-12. So in the concept side, we have computer systems, networks and the internet, data and analysis, algorithms and programming, and the impacts of computing. In core practices, we found that it showed fostering an inclusive computing culture, collaborating around computing, recognizing and defining computational problems, developing and using abstractions, creating computational artifacts, testing and refining computational artifacts, and communicating about computing. So, when we started to delve into this, we wanted to figure out okay, let's remove ourselves from the more scholastic, official kind of context approach and figure out how we could use unplugged activities. And in the research, we saw things like what you see on the screen now. So, to learn binaries, there's a really neat practice of using those cards. The kids make their cards in the top left, and then they start to use them to figure out how to write and compose binary code. And it seemed to be pretty effective. So, we'll go into these different studies later. To the right, you can see that a person is trying to walk through a computer grid to go and find the ball. So other people have to instruct them on how to get there, which helps with the idea of how to write the coding and use directions in the coordinate plane in a computational environment. At the bottom left, you can see something out of Indonesia where they came up with a role play where people are ALUs, CPUs, and the person is the display, and it allows the students to actively go through how the CPU works, how it calls upon the ALU to do computations, and then how eventually things are put onto our screens through the display. Then to the bottom right, you can see another activity that was devised. I think this one is from Italy, and they have a bunch of tiles set up on the floor similar to the basketball one above it, and they created a little robot outfit. So a robot had to move around the room and get to different targets. So those are all unplugged activities which bring in kinesthetic learning. And that approach works for a lot of people for the basic introductions for computer science. So in that first activity, this is the one with all those cards, and they get to visualize the 2 to the 0, 2 to the 1, etc. for the binary code and see how you would compose those numbers. So this is the first part of that activity. They see all the cards and the positioning for the binaries. Then they see some cards are flipped over and some are not. And when that happens, they say no if the card is not in use. And then they learn that a no would convert into a 0 for the binary code. If they see dots, then they would say yes, the card is in use, and a yes would turn into a 1. So it's just a foundational step to develop the binary numbers. In the second one, you can see the grid with the basketball, and that is where the student is first positioned onto the grid. And then in the picture to the right, you can see the really basic code that they're setting up for themselves with left and forward, and to the right for the movements that the person would need to get across their grid to the basketball. For students who are already understanding the concept, it's nice to use this particular activity for reinforcement. So there's a sorting algorithm to figure out, which box, which character is heavier than the other. And this one teaches them how to sort. So I know the professor has introduced one based off of height that was used in the classroom. This would be a solidifying experience that could then be used beyond that one. So this one is not the kinesthetic one, it's just a reinforcement activity that we found. And it helps the students to figure out how to sort different concepts. In the Israeli study, they actually had sort of mixed results from the people that they were running the study on, and some of them found that the kinesthetic learning was good for them, and some of them didn't really, I think, understand that they were learning ideas indirectly through the kinesthetic activities. But what they did get to find out is that they're the most efficient. So it's the easiest method to directly solve problems. And they could create higher efficiency by walking through these activities and exercises and saying, hey, you know what? It's not good to go back and forth a bunch of times on the floor to get to the basketball. It's better to just try to do something as close to a diagonal as you can. And that would be the efficiency concept. What they also found is the requirements for better learning would be this list of four. So, how to make things function in a better way, elicit existing ideas that are related to the acquired knowledge or to the planned acquired knowledge, and then to introduce some new ideas. So, drawing from past knowledge to help bring in some new ideas, and then developing criteria for evaluating the new ideas that are being acquired. So that's where they start to use CS Computer Science Unplugged. And that's to build on developing notions of an existing coordinate plane, let's say, and then try to develop, okay, there's the idea that there's a being or a robot that has to be moved from one side of a screen to the other. And then they can sort ideas out. So they get to go through and say, you know what, this one worked, this one didn't work, and their efficiency gets built in that manner. This is the study out of Indonesia, where the class is divided into teams of 3 or 4, and the students take on these different roles in a role play. There's the CPU role player who's given the program prompt for what needs to happen or occur. There's a CPU role, and that person has to delegate information to the ALU and then also figure out how to coordinate the grid. And the ALU person would convey the grid coordinates to the display so that they could be graphed on the board at the front of the room. And they found that this one was quite effective. The students really had a great time, and it builds permanent memory for these different applied situations. The students self-reported that the learning that was done was not felt like the learning in general, but rather like playing, and it was very exciting. And they also found that the involvement of CS Unplugged and Raspberry Pi proved to be able to increase the students' interest and enthusiasm in learning basic computers. And as we've heard many times before, if you have a lot of enthusiasm, oftentimes it means people will perform better at a task and they'll retain more information. 67 people out of 88 were able to exceed the minimum requirements from this study, which shows that there is a strong impact and effect on kinesthetic learning also. As students became direct participants in activities, the test progress of understanding increased. From this Italian research with the robot that was created, they found that a lot of different ideas are grounded in sensory motor experiences. And that when they provided these concrete situations, students could picture and involve themselves in processes that they could later see and use in computer science practice. And they called this enactivist framework. The authors propose that students will actively learn to determine logical steps to create an action from a given goal by using their normal ability to address a problem and solve it in the real world. And the results were having good mental rotation increases an individual's likelihood of giving correct responses in the coding test. So by physically doing something on a live coordinate plane and moving around and picturing it in live 3D, they were able to do a lot better when they had to figure it out in an actual computer context. So, the translation of what has happened with the results from the Italian study was that kinesthetic unplugged learning created a goal related situation in real life that conveyed the underlying concepts of coding in an understandable way that achieved better test results in the end. The activity is basically what's on the screen right now. The main topics involved for the walking activity are an algorithm, coding, and debugging. They used a large chessboard of 24 tiles, and the child on the screen to the right is playing the role of the robot Tino. They would have to move across the chessboard and physically execute a sequence of simple instructions. So the other students would direct the robot to the goal and use logical sequences to get them from one point to the next, as they would later have to do on a computer. It seems that the approach may be more readily accepted because students are still in control of their environment. So that's sort of what we found from all these kinesthetic studies, that because there is no computer that cannot respond or communicate back, that the students didn't feel as worried or nervous to do these different activities. Whereas if they're facing a computer screen, the computer screen can't suddenly help them and tell them what to do. But by doing this with students surrounding them in a physical context, everyone gets to see something enacted and then try to do something using the computer itself. So they're psychologically less pressured and it's less stressful. So, in essence, that's what this um, particular slide is about. The computer is not giving them an error message without any ability to communicate or move the inner workings of the machine. Instead, the children still have the ability to see and interact with their goals. So it is less stressful and it makes the underlying tasks more manageable. Also, they're working as a team or as an entire class with a goal that they can all disassemble, analyze, and complete. Overall, teaching programming from a specific tool's perspective, for example, learning Scratch or learning Python with closed-ended solutions does not alone develop deep understanding and wicked problem-solving skills. Teachers should engage students in learning to program by focusing on relevant problems that students could solve using programming as a tool when planning, conducting, and assessing a broad and inclusive computer science education. So, in conclusion, through the use of kinesthetic and unplugged learning, students are better able to place themselves mentally in the thought patterns that computers must use and then determine the best approach in working through the computer to achieve their goal. Kinesthetic and unplugged learning must be used to teach computer science as it is highly effective in improving understanding and showing that through better test performance. And these are our references used. Thanks for watching and have a great day, you guys. We appreciate it.